everyone, welcome back to my channel. In today's video, we are going to dive into one of the most popular and efficient sorting algorithm, which is quicksort. So, we are going to cover what it is, how it works, and walk through the code step by step with clear explanations. So, let's get started. Okay, do you guys have an idea about what quicksort is? Let me explain what it is. Let's move on to a simple introduction to quicksort. As it is in the name, quicksort, quick. As it is in the name, it is one of the fastest sorting algorithm, and it is also popular and efficient sorting algorithm. This sorting algorithm takes an array of values, chooses one of the values as the pivot element and moves the other values so that lower values are on the left of the pivot and the higher values are on the right of it. And it is based on the divide and conquer strategy. As I said earlier, it is done by selecting the pivot element and then sorting values larger than it on one side and smaller values on the other side. Then it repeats those steps until the array is sorted. It is very much useful in sorting big data sets. And this sorting is faster than many other sorting methods like bubble sort and insertion sort. So let's dive widely into what is quicksort, how it works, and some code explanations to understand very much about quicksort. Okay, now let's dive more deeply into quicksort. Now, sorting is a way of arranging items in a systematic manner. So, quicksort is a widely used sorting algorithm which makes n-log n comparisons in average case for sorting an array of n elements. It is faster and highly efficient sorting algorithm. And also, this algorithm follows the divide and conquer strategy or the approach. Let's see what quicksort is and get a clear understanding idea about it. Next, when we talk about quicksort works by recursively sorting the sublists to either side of the given pivot and dynamically shifting the elements inside the list around the pivot. As a result, quicksort method can be summarized into 3 steps. It can be 3 or 4. Mainly there are 3 steps. The first one is divide, then conquer and combine. When it comes to divide, first we must pick the pivot element. Here in this image that we can see, the pivot element is the value with 7. The firstmost step is to choose the pivot element. After that, partition or rearrange the array in 2 subarrays such that each element in the left subarray is less than or equal to the pivot element and each element in the right is larger than the pivot element. When it is sorted, it must be like this. The smaller values must be in the left side and the larger values must be in the right side of the pivot element. Conquer means recursively sorting 2 subarrays with quicksort. Next, we must combine the already sorted array. After sorting, we must combine everything together. At last, we must repeat these steps and combine the arrays that have previously sorted. And this is what we discussed so far. First we must pick an element, then divide, then recurse and conquer. When it comes to the key steps of quicksort, the first key step is how to pick a pivot element and then how to partition. When it comes to picking a pivot, as it is the very first step in quicksort, because the process starts by selecting one element which is known as pivot from the list. Picking a good pivot is very much necessary, and it is necessary for the fast implementation of the quicksort too. However, it is difficult to determine a good pivot. Some of the ways of choosing a pivot is a pivot can be random. For example, it can be selected randomly from the given array. Next, it can be either the first element or the last element of an array. Also, it can be a middle element of the given array. If we comes to partition using an example, it's like this. Now here we have an array. Here we have an array 5, 6, 4, 6, 3, 12 and 19. So our goal is to correctly position the pivot element. We'll choose 6 here as the pivot element. This is the pivot element. Then before starting, we must move the pivot to the end of the array, end or the last element in the array. So after swapping, it will look like this. Now the pivot is safely sitting at the end, so now we can start partitioning. Now we must start partitioning. Here we first check for the value 5, the first index, whether it is smaller than 6. Yes, it's smaller than 6, so it stays in the same position. So we move, the I value changes into the next element, and here we, after checking for I, we must check for J. Here we check from the right side for the value 12. We are checking whether it is larger than our pivot. So since it is larger than our pivot, it also stays in the same place. So after the changes, it looks like this. The element we checked at first and next remains in the same position. Next, we are going to check for the next two elements, the value 6 and 3. Now here we must check whether it is less than or equal to our pivot. When we are checking 6 is equal to our pivot and our J element 3 is less than our pivot, but it's not larger than the pivot, so the position of it is not correct. Next, we must swap these two elements. We must swap 6 and 3 since they are not in the correct position. After swapping, it may look like this. It has come to the correct position. After that, our next step will be, now here we can see the things we sorted is in the correct place. Next we are checking for 19 and 4. If we check for 19, it is larger than our pivot element. If we check for our next value number 4, it is less than our pivot element. But here, since this is much larger than our pivot element, we must swap it with our pivot element. Next, 19 and 6 will be swapped. Here now we can see that our pivot element has come to the correct position. So next, it remains in the same position, and the other elements must be sorted by repeating these steps again and again. Now here is an example for the quick sort. Now let's look at the quick sort source code using Java programming language. Here first we have the partition method. Inside the quicksort class, here we pick the rightmost element as the pivot. This is the coding for that. Then we rearrange the array so that all the elements is smaller than or equal to the pivot come to its left, and greater elements comes to its right. We use 2 pointers, namely I and j, where I keeps track of the smaller elements and the j moves through the array comparing each value with the pivot. Here we initialize I, and next we implement j here using the for loop. Next, every time we find the element smaller than or equal to the pivot, we increase I and swap the elements at I and j. Finally, after going through the array, we swap the pivot element right after I, placing the pivot in the correct position. In the sorted array. So this is the coding part for the placing the pivot in its correct position. Next, when we look at the other part of this code, it is we can see the main quicksort function. Here the function is here in this code. So we have the quicksort method itself. This function applies the divide and conquer approach. It first checks if the array section we are looking at has more than one element. Then if it is like that, then it calls the partition method to place the pivot in its correct spot. Then after that it calls itself recursively on the left and right parts of the array, sorting smaller pieces until everything is in order. At last we can see our main method. This is our main method. We start with an array named 23 with the values 23, 9, 18, 32, 61 and 50. Then we call the quicksort function with the first and the last index. After sorting is done, we print the sorted array. This is the coding part for that. Then the sorted array will looks like 9, 18, 18, then 23, after that 32, 50 and 61. So this is how this coding will do the quick sort. So if we quickly recap how to do quick sort, first we must choose the pivot. It places the pivot in the right position using partition. Then it recursively sorts the left and right paths, and then call the main method. Now if we talk about the complexity of the quicksort, these are the complexity cases. The best case is indicated like this, then average case performance, worst case space complexity auxiliary, where n is the number of elements to be sorted. Next, if we talk about the applications of quicksort, we can see quicksort in database management for indexing, and also in computer graphics. When it comes to computer graphics, in depth sorting and texture mapping. Next, in text processing and network applications. And it is the end of my explanation. Now let's see how this quick sort, a small video, a small demonstration about quick sort. This is the demonstration of quick sort. First, our last element is the pivot. Next, we compare the value or the height of the other elements, whether they are less than the pivot. Now if it is less, we we increment the bottle, we move the bottle by 1, and then if it is greater, the other element's value is greater than the pivot, we stays in the same place. Now after getting the correct place of the pivot, we keep it at the correct place and other elements move one step forward. Now here we can see that if the value is less than the pivot, it swaps with itself and moves the bottle one step. Now likewise, we repeat the same steps until the array gets sorted. Now after getting all getting compared and being sorted, we merge each other into the final array.